So have you ever wondered how drifting works? Well, I'm going to try to explain it to you right now. So as you're moving in your car, you have your velocity vector, which is pretty much your inertia, it's the way you're traveling, and you have the acceleration force that your tires put on, exert onto the floor that actually pushes your car forward. So what happens is, as you're going into a turn, once you start pushing your back end out, at the initial state, once your car is sideways before you start accelerating, your velocity vector is still the same way. Nothing has really changed. There's slight variations as you turn, the friction in your tires, sidewalls, and it wants to kind of go straight, but this is pretty much what it is. So once you start accelerating, this velocity vector right here will start pushing over. So this is actually, the velocity vector is the direction your car is traveling in. So once your velocity vector starts to change, your car starts to move in that way. So right here it's moving upwards, right here the car will, if it's remains stable, will keep going that way. But that force right here is actually pushing it forward. So as it's going to keep turning, this velocity vector is going to keep changing with the turn. So what's actually happening here? So I'm going to take this part right here, and I'm going to try to break this thing up. So what we're doing here is, this is your acceleration force, and this is your velocity vector. So as we're out here, we're going to have the x plane and y plane. So we can actually separate each of these vectors into each component in terms of x and y. So for this velocity vector here, we actually have one vector pushing to the left and one vector pushing upwards. And for the acceleration force, we have one that's pushing left again and one that's pushing down. So what happens then? These forces right here, these two vectors are actually combining with each other. Now these aren't to scale, but right here we have these two different vectors adding together in each of their components. So we're going to split it up once more to make it even easier. So we have this force that's pushing us to the left, added with another force that's still pushing us to the left, and we're going to get a bigger one to the left. And also, we have one force that's pushing us upwards and another that's pushing us downwards. This is again all in relation to this xy. So what we're going to get, considering, or assuming rather, that this is bigger than this, we're also assuming that this again is bigger than that, we're going to get a smaller up arrow. So what happens is when you put these together, you get something like this, which turns out to turn into something like this. So this is ever so slightly just tilting it inwards. So as you're moving the car along, as it's pushing itself forward, what it's actually doing is just changing this velocity vector to keep up with the turn. And that's pretty much what drifting is.